Okay, May, June 2018, paper 6, variant 2. Question 1, a student is determining the density of water. She is provided with a plastic cup as shown in figure 1.1. She draws around the base of the cup. Her drawing is shown in figure 1.2. From figure 1.2, take and record measurements to determine an accurate value for the diameter dB of the base cup. Can I measure the diameter of this circle? Yes, definitely we can measure the diameter of the circle. Using the ruler, you need to find the longest length. The longest length. If you have printed out this paper, probably the length would be around 4.7. Okay, the length should be around 4.7 centimeters. 4.7, 4.8, okay, centimeters. When dt is equal to 7.2, can I find the average diameter of d? Can I find the average diameter of? Yes, I can find the average. Just add 4.7 plus 7.2 over 2. 4.7 plus 7.2 over 2. This would give you an average diameter of 5.95. Okay, 5.95 centimeters. Next question, can I measure the height? Okay, can I measure the height of this cup? Yes, I can measure the height of the cup. The height of this cup would be around, I guess if you use your ruler, it would be around 7.8 centimeters. 7.8 centimeters. Can I find the volume using this equation? V equals 0.785 d squared. Okay, so 0.785 times the d squared was 5.95. 5.95 squared times h, which is 7.8, so times 7.8. This would give you a volume of around 217 centimeters cubed. 217 centimeters cubed. The student fills up the cup of water. The mass of the cup with the water is shown. Can I find the density using this equation? This density equals mass over volume. So the mass is 232, the volume is 217. So basically 232 divided by 217, which is 1.07. Again, do not forget the unit, include the unit. Grams per centimeters cubed. Grams per centimeter cubed. Suggest with a reason a part of the procedure A, B, or C that could give an unreliable result for the density of water. You could have more than one correct answer for this question. One of the easiest answers you could think of for this question is, okay, for example, in my opinion, it would be in part C. Why especially in part C? Because when he took the mass of the water, the reading on the balance, he took the reading of the whole cup, the cup and the water, which is wrong. Why? Because this reading includes the mass of the cup itself. The mass of the cup could be a couple of grams. So you need to first of all find the mass of the cup on its own without the water and then subtract it from the total mass to find the mass of the water alone in order to find the density of this liquid of water. So I'll say in part C. Why especially in part C? Because the mass taken was including, okay, the mass of the cup. Okay, you need to subtract the mass of the empty cup. The student pours, okay, the student pours the water from the cup into a measuring cylinder. Draw a diagram to show water in the measuring cylinder. Show clearly the meniscus and the line of sight. Okay, that's easy. Can I draw a measuring cylinder this way? Okay, this is my measuring cylinder. Inside the measuring cylinder, the water would bend this way. It would kind of curve this way, with the meniscus being downwards. And you need to take the reading from the bottom of the meniscus, and you need to take the reading perpendicularly. Okay, so using a ruler, you should draw a straight line with an eye to show the line of sight. So this is an eye showing the line of sight from the bottom of the meniscus. From the bottom of the meniscus. This is the water, level of the water, and so on. Yeah. Now we have a thermometer. Can I take the theta r, the room temperature of this experiment? Yes, I can take theta r. Theta r is 23 degrees Celsius. 23 degrees Celsius. The student pours 200 centimeters cubed of hot water into the beaker. He records the temperature theta h of hot water at time t equals 0 and immediately starts the stop clock. He continues recording the temperature readings every 30 seconds. The readings are shown in table 2.1. In I, he's asking, explain why the student should wait a few seconds after placing the thermometer in the hot water before taking the first temperature reading, which is one of the precautions we usually say. This is one of the precautions we usually say in whenever dealing with a thermometer. We should make sure that the temperature of the thermometer has reached the temperature of the water, because initially the temperature of the thermometer is colder than the temperature of the water, so you need to leave it in the water for a couple of seconds before taking the reading. Okay, so you need to make sure, why am I using the black pen? Anyway, make sure the temperature of the thermometer has reached the temperature of the hot water. Okay. Hmm. Now I have a table. I need to complete the column headings and I need to complete the time column. The column headings are quite easy because the time is in seconds. How do we make sure that the time is in seconds? Okay, she takes the reading every 30 seconds. Every 30 seconds. So time is in seconds and the theta is in degrees Celsius. We started off with 0 and then we need to increment 30, 60, 90, 120, 150 seconds. You could copy the table headings from this statement. Plot a graph of theta slash degrees Celsius, so you can just write down degrees Celsius, and time slash seconds, so you can just write down the seconds. You do not need to start the y-axis at origin. You do not need to start the y-axis at origin. So first of all, theta degrees Celsius on the y-axis and t slash seconds on the x-axis. Okay, I won't start from 0 and 0. I will not start the theta axis, the y-axis from 0 and 0. The x-axis would start from 0. Why? Because the initial temperature was taken at time 0. So you will start the x-axis at 0. But the y-axis, you will not start it from 0. You'll actually start it from a different number, but you have to make sure that the room temperature would be or is marked on the y-axis. You have to make sure that the room temperature is marked on the y-axis. What was the room temperature? It was 23 degrees Celsius. So you need to start off with something less than 23 degrees Celsius and plot the remaining points. So you have up to 70. You have the points to have the temperatures going up to 70. So let's check it out. If I say 20, 30, 40, 50, 60, 70. Okay, it's not too bad. Not too bad at all. because we have the highest. Uh, what about the numbers on the x-axis? We have 0, 30, up to 150. So can I start with 0? Okay. 30, 60, 90, 120, 150. Can I use a different scale? Yes, I can use a different scale. This wouldn't be the best scale. If you use 30, 60, 90, 120, 150, it wouldn't be the best scale. Can I actually increase it a bit? Yes, I can use 20s. Let's try it out. 20, 40, 60, 80, 100, 120, 140, and 150, 160, I mean. Oh, yes, this is much better. Why? Because the last number would be plotted at this point, and the first number would be plotted at this point. So basically, you're taking almost all of the graph. So this is a much better scale. Okay, let's start plotting 0 and 70, wasn't it? Yes, 0 and 70. We can plot a very small x. Okay, 0 and 70. The second point was 30 and 60. So 30 and 60 would be this point. Okay, again, very small x's. Okay, 60 and 52. 60 and 52, so above the 50. Two squares above 50. 90 and 49. One square below 50. 90 and 59. Okay. 120 and 46, 120 and 46, and 150 and 43, 150 and 43. So here it is, 150 and 43. I guess this is quite obvious that we wouldn't draw a best fit line. This is not a straight line. This is not a straight line. He did not state in the question that you have to draw a straight line or a curve or whatever. You need to think about it. Okay? If you check out the points, the points are definitely a curve. This is definitely a curve. And we said before that any rate of cooling graph would be a curve, would be a decreasing slope. Uh, okay, so let's draw the curve. A continuous line. Do not just join every 2 points together. No, you need to draw a continuous line. Okay, sort of with your hands. If the if the line doesn't pass through all of the points, it's okay. It's okay if the line does not pass through all of the points. Again, this is a best fit curve. Best fit curve. So you do not need to pass through all of the points. Okay, I hope that's quite clear. But what's more important is that the line should be continuous. That is what is more important while drawing this line. In question C, he's asking draw a horizontal line across the graph to indicate the value of the room temperature theta r as shown by the thermometer in figure 2.2. That's why he said you need to indicate point theta r. Theta r was what? Was 23. So at this point, this is 23. Theta r, you have to draw a horizontal line using the ruler. Using a ruler. So draw a horizontal line on 23. Please draw it accurately. Definitely, I cannot draw it accurately because I do not have a ruler. But again, you should draw using a ruler. Okay, exactly on 23, a line which is the room temperature. Okay, it's quite obvious that the curve is bending towards, or it's going towards the theta r, towards the room temperature. And this is the whole point of the cooling experiment, rate of cooling experiment. State 2 precautions that you would take in order to obtain accurate readings in this experiment. What are 2 precautions that you would take? 2 very important precautions taken in this experiment would be what? First of all, you need to take the reading of the um, of the thermometer perpendicularly. Why? To avoid the parallax error. right? And then you need to stir the water gently. Stir the water gently. So take the reading of the thermometer gently, gently, perpendicularly, perpendicularly. Why? To avoid the parallax error. And question two, or the second point is stir the water gently. Two very important precautions. Hmm. Next question. A student plans to repeat the experiment, okay, using the same thermometer and the same volume of water. Suggest two changes to the apparatus or the procedure that would increase the rate of cooling of water. So how can I increase the rate of cooling of water? Increasing the rate of cooling of water would need to we have several variables that could increase the rate of cooling of water. First of which would be increasing the initial temperature. Increasing, okay, the initial temperature of water. The initial temperature of the water. If you increase the initial temperature of the water, it would be it would give a much higher rate of cooling. You could also you could also decrease the room temperature. The whole point is finding a larger difference between the initial temperature of the water and the room temperature. Whenever the difference between these two temperatures is much higher, the rate of cooling is much greater. Okay, whenever you increase the difference between the temperature of the water and the room temperature, then the rate of cooling is much greater. Okay, so you can increase the initial temperature of the water, you can decrease the room temperature. You can increase, for example, the surface area of the beaker. You can get a new beaker with a larger surface area, which would increase the rate of cooling of water. Okay. Okay, a student is determining the focal length of a lens. The student adjusts the position of the screen until a clearly focused image is formed on the screen. On figure 3.1, measure the distance V between the center of the lens and the screen. Can I use the ruler to find the distance? Yes, I can find the distance. It would be around 5.8. Around 5.8. Again, do not forget the unit, centimeters. 5.8 centimeters. Figure 3.1 is drawn 1/5 actual scale. 1/5 actual scale. Can I find the actual distance? Can I find the actual distance? If it's 1/5, if it is 1/5. So all you do is 5.8 divided by 1 over 5, or basically 5.8 times 5. 5.8 times 5, which is 29 centimeters. So the actual distance is 29 centimeters. Can I find the actual focal length? Can I find F1 using the equation? Okay, quite simple. UV over U plus V. So 29 times 20 over 29 plus 20. You can just plug it in your calculator, and the F would be 11.8 centimeters. 11.8 centimeters. Hmm. Can I find the average focal length? I have F1 and F2. Can I find the average focal length? Yes, that's quite easy. F1 plus F2 over 2. So basically 11.8 plus 12.2 over 2, which would give you 12 centimeters. This is the average focal length. This is the average focal length. Student states that taking more measurements improves the reliability of the value obtained for FA. Suggest additional values for U that you would use. Not for you as in, I mean U as the distance. Ah, suggest additional values for U. What was U? U was 20, wasn't it? It was 20. Hmm. Can I find or can I state different values, several values of U? Yes, you need at least five values. You need at least five values. So should I go above or below? As you like. Okay, as you like. You can go, for example, you could take a number or one value less than 20. You can say 10 centimeters. You can say 15 centimeters, and then you can go above 20. So if I say 15 centimeters, and then I go above 20, 25 centimeters, 30, 35. 40. If you want to go on, at least, I'm saying at least 5 centimeters, at least five values. You can say six, seven, whatever number of values you'd like. State two precautions that you would take in this experiment to obtain accurate readings. Accurate readings in this experiment would be, first of all, this is an experiment, focal length and lens and whatever. So first of all, you need a dark room. You need a dark room. So use a dark room. Use a dark room. Definitely. If the room isn't dark, okay, if the room isn't dark, it wouldn't be accurate. You wouldn't find the image to be that clear. You need the image to be clear. How can I find the image clearly? By using a dark room. Okay. Okay. What about the second precaution? The second precaution, this experiment would be, for example, you could say, make sure that all of the lens and the screen and the object are all on the same horizontal surface. Make sure that the lens, okay, so you need to make, okay, sure that that the lens, the object and screen are all on the same horizontal surface. Horizontal are all on the same horizontal surface. Okay. A student investigating whether the distance, planning an experiment, whether the distance that a toy truck will travel along a horizontal floor before stopping depends on its mass. Depends on its mass. So I think from this sentence, we do understand that we need to change what? We need to change the mass of this toy truck. The following apparatus is available: a ramp, blocks to support the ramp, toy truck, a selection of masses, other standard apparatus from the physics lab. Okay, plan an experiment. Plan an experiment to investigate whether the distance that a toy truck will travel along the horizontal floor depends on its mass. Does it depend on the mass or not? So the independent variable, the range of values, would be the mass of this toy truck. Mass of this toy truck. So it's a truck, you'll keep on adding some masses to the truck, and you would see, as seen in the figure, the toy truck would start, for example, at this point, and you would keep on adding masses. So this is our truck. It would travel a distance and stop. It would travel a distance. So we need to measure this distance. You need to measure this distance, okay? And then repeat the experiment with a different mass and test. So you need to see whether the distance would be different or not. Explain. Okay, so you need to explain the procedure. You need to state any apparatuses that you would use, key variables. Okay, draw a table, and definitely we would write down a conclusion, a very simple conclusion. Good. First of all, let's write down the steps. Okay, we know we need to write down the thing that we will be changing, the range of values. The range, let's zoom in a bit. Okay, range of values. The independent variables. So We're talking about the mass of the truck. And since this is a toy truck, so definitely it would be quite reasonable to not use very huge masses. To not use very huge. So I'm talking 10 grams, 20 grams, 30 grams, 40, and 50 grams. Do not go above 50 grams. It's a very small toy truck. Range of values. Now, and then we need to state the controlled variables. Controlled uh, variables. Some of which might be the slope of the ramp. Slope of the ramp. Hmm? You can say the height of the wooden blocks. The height of the block. So if you're using 3 blocks, only use 3 blocks. Okay? The height of. And definitely another very important point, another very important controlled variable would be the position. Okay? Position at which, okay, the truck will start. Okay, the position at which this truck will start. Okay, you have to leave the truck at the same position. You have to start the truck from the same position each time. Controlled variables. And then, what are the apparatuses needed? Apparatuses needed. Let's check out what are the things we need to measure. We need to measure 2 things. You need to measure the mass and you need to measure the distance. So basically, you need to write down the balance and you need to write down the ruler. Balance and the ruler. And then, what are the steps? How can I conduct this experiment? It's a very easy experiment. It's a very easy experiment. First of all, you need to let the truck, let go of the truck from the same position each time, definitely from the same position, and leave the truck, slide down the ramp. Measure the distance traveled from the bottom of the ramp until it stops. From the bottom of the ramp until it stops. So place the truck on the ramp, okay, and then leave the truck, slide down the ramp. Measure measure the distance traveled from the bottom of the ramp until it stops. That's it. That's it. Yeah, repeat and take average. Yes, I will state that. I will state it in the conclusion. I will state, repeat, and take average. There are no precautions in this question, so you don't need to write down any precautions. Can I write down the table? Can I draw the table? Yes, table is quite easy because all you need to do write in the table are the mass and the distance traveled. Mass of the truck in grams and the distance traveled in centimeters. That's all you need to write down in the table. Okay? Let's go on to the conclusion. Conclusion. We say in the conclusion, first of all, for each mass, yes, for each mass. Repeat the experiment. Repeat the experiment and take average. For each mass, repeat the experiment and take average. Record the readings. Record the readings in the table, readings in the table. When you record the readings in the table, you can compare the results, using a graph. You can plot the points using a graph and see whether the mass would increase the distance or not. Okay? Okay.